works. I looked at the agenda, and I know that you had a very interesting session in the morning, but it was all in Swedish, so I decided not to come. But fortunately, all of you understand English, and I apologize, I have to speak English because I don't speak Swedish. Um, um, my name is Andrei Robachevsky. I work for the Internet Society, sort of central, as Marie said. I'll be talking about MANRS, this initiative, but would like to start with a more general question about routing security. But I mean, the title of this presentation is that routing security is at risk. Let's secure it together, but is it really at risk? I mean, we know there a lot of things happening. We read in the press about routing incidents. There was one recently with a leak somewhere in the world that affected another company else in completely another part of the world. Let me start at looking at the problem first, and then come to the potential solution or a range of solutions. So to answer quickly the question, is something happening in the internet? Yes, that's happening a lot. I pulled this graph. It's an old graph, but things are not changing much. From a service called BGP Stream. And what they do, they look at the routing system from different vantage points and see if there are changes in the routing system that are suspicious. Like one network announced the prefix, and all of a sudden another network starts originating the prefix that doesn't belong to them, typical hijack, or some interesting detour in traffic that would qualify as a route leak. So I pulled this data for 3 months, and you see there are a lot of things happening. Every day there are about like 20 and sometimes 100. So dozens of incidents happen on the internet on different scale. We don't know the impact. So I went further. I was interested. What is behind? And I pulled this data even more for 1 year, 2017. That's what I did, and counted about 14,000 incidents happening in the internet. Now, the BGP Stream is an operational service. It supplies data to operators who are interested in monitoring, and it's a monitoring service. So one of the things that they do, they minimize false positives, which means most probably there are more than 14,000 incidents on the internet. Those are with high probability real incidents that operators should pay attention. Another caveat that I made some geographical mapping, and I used this kind of MaxMind mapping service, which not always accurately map networks and resources, right? Especially if we talk about global companies. So with those caveats, I would like to show you some of the things. So in 2017, as I said, there were 14,000 incidents all over the place. Those were outages as well, not only security incidents like hijacks and route leaks, but about 40% of them were really security incidents. Over 10% of all networks on the internet, and right now it's about 63,000 networks, so about 10% of all networks were affected. 3,000 systems were a victim of at least one incident, and 1,500 networks were a culprit. They caused this incident, they caused pain to some other networks. Now, those are numbers, and well, they tell us something, but what's more important is look at the dynamics. Unfortunately, while the year hasn't finished yet, I plan to do a similar exercise at the end of 2018. But what I did some time ago, I took 5 months of 2018 to look how data looks for those first 5 months of this year. And well, I have to tell you, I mean, I was positively surprised. I think if we go like this with the first 5 months, if the trend continues, we'll be much better off at the end of 2018. Because compared to this, you see it's almost 1/3 of what happened in 2017 in terms of culprits, in terms of networks causing responsible for those incidents. Well, you see the number of incidents also significantly reduced. I mean, bear in mind this is almost half a year data, right? So it's not full year, but it's not like twice as less as here. So that's a positive statistics. Now, if we look at geography, potential victims, I looked at networks that were affected by the incidents. Again, we don't know to what extent they were affected, whether the customers complained, how long the outage. I was just counting the instances of those incidents. So you can see.
Do you mean victim here as in who got hijacked? Or
Yes, yes, for instance.
Right, so this is for, is this on? Maybe, yeah. So when you mean victim here, do you mean the one that, you know, got affected by hijack, or the one that got hijacked? For example, would a company like Google would be counted in the US region there because they got hijacked a couple of times, so they are the victim in this case, and not me as a user of the service? Or
yes,
right.
that's the company, and with the caveat I mentioned about mapping to a particular geography. Yes, in this case that would be Google. Like when YouTube was hijacked by Pakistan Telecom, Google would appear here, right on this list of victims. And in absolute numbers, yeah, US, Brazil, India are the most sort of victimized countries. But the thing is, of course, absolute numbers tell only part of the story, because those are big countries as well. There are a lot of networks operating there. So on the right side graph, I put the percentages. So it's percent of networks operating in particular country that got victimized. So you can see that, for instance, and it changes slightly. So US is not in such a bad shape. You can see that it's about 4% of networks that got victimized at least once in a year. But like Bangladesh, like Iran, like India, Hong Kong, again, Hong Kong maybe just a geography thing, right? But they are reaching like 10%, even 15% of their networks got hit by network incidents in 2017. It's getting much better in 2018, again with the caveat that it's only half a year that I analyzed, but you can see that those bars, the lighter blue bars, that's the percentage of networks were hit by incident in the first 5 months of 2018. It looks much better. Not for everyone, but for some of them, they really got better. I don't know why precisely, but that's a fact. So let's look at the culprits. I will not call the names, but I will I will look at general numbers. And again, this is absolute numbers, and Brazil stands out. And they're aware of that. They, as you may know, they are running a very ambitious project on country and national scale to secure internet from the exchange point of view, but also implement all those practices, and we are cooperating with MANRS on that side. But they stand out here in absolute numbers. Again, absolute numbers, part of the story. I normalize them by the number of networks operating country, and you can see 3 countries, again, very visible. That's Brazil, that's Hong Kong, and that's Iran. Yes, that's Iran, I think. And that's about, you know, almost 10% of networks are doing not right. They're hitting other networks with routing incidents, causing some maybe outages, maybe a denial of service. All right, well, that's the dynamics. That's the same data, but mapped 2017 versus 2018. And I would say that's impressive. I think that's a very positive dynamics. The number and percentage of those culprits reduced significantly. Look at Brazil. That's what they had in 2017. Now, I think there's a higher level of hygiene. I mean, we can speculate, and let's wait till 2018 ends, and I will run this data again for the whole year, so we can compare, you know, apples and apples. But I think that's clearly the routing hygiene, at least in first half 2018, improved significantly. So, as I said, this data just shows incidents. It might be just very short incident caused a little outage, was visible only in particular geography, didn't have any global spread, or maybe it was an incident that caused significant outage and was globally visible. From the data I showed, we don't know. But from the research that was done by some of the folks that analyze specific incidents, we know that those incidents that cause real life problems, right, that caused outage. And I put here 3 things that MANRS, the initiative I'm going to talk to you about, focuses on. This is prefix and route hijack, route leak, and IP address spoofing. So just a quick, I know that you probably all know what I'm talking about, but just a quick explanation. So what we mean by route hijack is that a network impersonates another network. They originate announcement. They say, well, your destination is in my network, right? That's a hijack. That's how Pakistan Telecom hijacked YouTube. That's a classical example. But there was a more recent one. I mean, 10 years later, and we still have, you know, someone hijacks DNS service of Amazon. All right? And people believe. That's the most amazing thing. Now, route leak is more subtle. Route leak is that, well, the networks that sort of emits this announcement, originates this route, is the same. It doesn't change. But the path it goes, the announcement goes through, it is modified, right? And that can be used by any man-in-the-middle attack. So if you want to create a man-in-the-middle attack, you have to get in the path, right? How do you get in the path, right, of an arbitrary communication? Route leaks allows you to do that. It actually was demonstrated that you can, with sort of a few connections to big networks, you can basically inject yourself in any path you like. I can inject myself in the path between specific clients and specific bank, or specific clients and, you know, well, if I can cope with the traffic, of course, right? In many cases, in many cases, that's the general opinion. It's not malice, it's misconfiguration. It's, for instance, when a client, multi-homed client, learns about the internet, all other destinations, including Google, including Facebook, on the internet from one provider, and announces this information to another provider. If no specific measures are taken, if care is not taken, that another provider would accept those routes, because usually customer routes are preferred, and that would cause a leak. So the customer becomes your transit provider, which is a bad thing usually, because customer is not capable of handling all this traffic, which causes outage if it's a misconfiguration. But as I said, we see more, sort of from this research, we see more carefully crafted, really malicious attacks that reroute specific traffic for specific amount of time for any activities. Take reconnaissance activity, for instance. Before mounting the attack, you need to understand the victim, right? What ports are maybe open, what communication lines are there. Now, doing this in active mode raises suspicion, right? If people detect that they're being scanned, they might prepare for an attack. Now, this allows you to monitor, even if traffic is encrypted, you can allow you to monitor what kind of communication channels are open at the victim side. Passively, no one notices. Well, finally, IP address spoofing, not specifically routing, but is related. It's related because the internet, as it's designed, doesn't take source IP address into consideration when routing is performed. So in fact, it doesn't matter what kind of source IP address. Of course, it matters for communication because your website needs to return an answer to the client, but in the routing sense, it doesn't matter. That causes source IP address spoofing, so an adversary can impersonate someone else as if this packet comes from somewhere else. And somewhere else is usually a victim. So that's how reflection amplification attacks are mounted. They usually work on datagram services like DNS, like NTP, and what happens is that the NTP server or DNS server thinks that those packets came from the victim and directs all the answers to that victim. And that might create a volumetric attack of 1.3 terabytes per second. That's a lot of traffic. And that smashes a lot of infrastructure on its way, not just a particular service. So it causes a major, major outage. So because of this research, because of those publications, because of those particular cases that were showcased, we know that those are significant things. This is a significant vulnerability. This is a significant problem. So, well, I mentioned to you, 10 years later, we still have those attacks. So what's happening? Well, I showed you positive dynamics as well, but still we are vulnerable. I think we cannot sleep well before that's done. Now, maybe we don't know how to do things. Maybe we don't have tools and technologies to protect. Well, no, I think prefix and IS path filtering were like in the best practices for ages. We have tools, various tools. Even BGP-SEC is standardized in the IETF, right? So, I mean, it's all there, but there is clearly not enough deployment, right? And the thing is, because BGP is based on trust, BGP, validation of announcements you're getting, and BGP, the protocol that supports global routing, it doesn't have built-in validation of those announcements. So it's really, if you look at the vanilla BGP, it's based on trust. If you tell me that I can reach those networks through you, I believe you, right? Now, if I'm careful, I should check, but I cannot check in the BGP. I have to check elsewhere, and elsewhere there are various repositories that contain this routing information, but they are incomplete and in many cases incorrect. And right now there are two major types of repositories that exist. One is so-called internet routing registries, and another one is sort of a nascent RPKI thing, where this information is more sort of technologically accessible and digitally signed. But more importantly, why is that happening? So when we talk about security, security is not a state as a process, right? That's why in corporate sense, people create those frameworks. They create processes, right? You don't become secure because you just patched your system. You become secure because you have a process, you have a patching policy, you have a process that allows you not to patch once, twice, or 3 times, but patch when it's needed and all the time. So you are all the time patched, right? But I mentioned to you 63,000 networks. They're independent. I mean, well, not all of them, but we can think of them, that many of them are independent. Right? How can you create this kind of systemic approach to security, global security, among those thousands of independent parties? That's a real challenge. That's why internet security in the internet is not a corporate network, is extremely challenging. So, another thing is that we are all dependent on each other. To put it other way, I mean, implementing best practices, of course, it contributes to your own network security. Not accepting bogus routes is good for the network because you can affect your customers. You can direct their traffic somewhere else. So it certainly has benefit. It certainly has business case. But to a large extent, security of your network depends on other operators. Well, let me come back to this YouTube incident, which happened 10 years ago. So YouTube could have done only so much to protect themselves. It was PCCW, upstream provider of Pakistan Telecom, or Pakistan Telecom themselves, who could have protected YouTube. Imagine, I mean, YouTube and Pakistan Telecom. It's like they have no relationship, absolutely nothing. So how do you do this kind of systemic approach? So security of your network is in the hands of other operators, maybe your competitors. So that calls really for this collaborative approach, because alone you cannot secure yourself and you cannot secure the internet. So this is one of the approaches that we're suggesting. That's not the solution, right? It's one of the approaches, and it's not technology. It's more socio-economic thing, because that's what hinders deployment of security in the internet in general. So what is MANRS? MANRS, which stands for Mutually Agreed Norms for Routing Security. It's a, well, you can think of this as a movement. You can think of this as a collective action. What it does, it defines 4 actions, right? And that looks like a best practice. Well, it's not a best practice, it's actually a baseline. It's a minimum norm that you must implement, right? Best practices sometimes shoot for the sky, but this is a very basic thing, that very basic routing hygiene that you need, a network needs to implement. But this still looks like a recommendation, right? What is different here is that the networks that would like to join MANRS, they need to implement those things and need to demonstrate that those actions are implemented. And by joining this, they create a community. They create visible community of people that implement those actions. And if you want to move this level of hygiene as a norm, right? Like wash your hands after the bathroom, right? Basic norms. We need this community. We need to demonstrate that it's not a document. It's not just 4 actions, you know, that we knew for ages. It's hundreds of people, hundreds of networks that support that, right? We need to make more visible on the internet good behavior from bad behavior. So let me talk about the actions. And those actions, if you look at the titles especially, they look like motherhood and apple pie. Come on, we knew this for ages. What are you going to change here? Well, first of all, they're very much tailored. They tailor it for low cost, low risk, right? It's really easy to implement this stuff. This is very basic stuff. That's the most essential thing that you need to implement. So if those actions are implemented on a bigger scale, we have a much better routing security, right? So what are they? They're filtering, and they talk about your side of the street. Do whatever you want, right? You cannot secure the global routing, but you can secure your customer account. You can ensure that your customers, even if they announce something wrong, this announcement doesn't propagate further than your network, right? So you filter them. That's your customers and your own network. The same for anti-spoofing. Anti-spoofing works best at the edge. The closer you to the source, the more information, the more confidence you have that this is a spoofed traffic, right? For somewhere in the transit land, it's impossible to say, is it a spoof traffic or is it a legitimate traffic, right? For DNS reflector, it's very difficult to say, well, is it a spoof traffic or is it a real traffic? So the closer you to the edge, to this adversary, the easier for you to implement anti-spoofing. That's again the thing. We are talking about this kind of, you know, edge networks. Coordination. It's a very simple action. Make your contacts publicly available and accessible. But coordination is a crucial thing when you trying to mitigate an attack, when you need to contact a network with which you have no business or otherwise relationship. So small action, easy to implement, but very important. And finally, global validation. Well, the title is misleading. It's facilitating global validation. MANRS doesn't ask for global validation. It's not a minimum norm, for sure. But what you can do, you can publish your routing information in those repositories I mentioned. And I told you at the beginning that this is one of the things that hinders deployment of those security technologies, is lack of reliable data. So that action, the 4th action, it actually contributes to this reliable data, making more accurate and making more complete. Now, as I told you, it's not the solution. It's one step. I think it's a way to also raise awareness, ignite communities, right? That's why we are coming around and we are talking to network operators. It's impossible. It doesn't scale if we do this one by one, right? And say, well, why don't you sign up? Why don't you sign up, right? My travel budget would be enormous, but we will achieve little. So what is important is that we try to ignite communities, that communities take routing security on board in their discourse and their discussions, and they see how we, as a networking community, because we also depend on each other, right, can improve routing security. MANRS is a global reference point, right? It's a useful framework. So if all of us sort of align these efforts around one framework, I think we can achieve better results. That's where we see MANRS' role, right? Not as all-encompassing thing, but as a useful global reference for such discussions, is a useful single point where you can see all the networks that demonstrate leadership and good behavior in routing. So what is it for a network to implement MANRS? Well, I told you, there is a business case for implementing those things as such, right? Because you're not accepting bogus information, you're not emitting bogus information, you're not inflicting on yourself. If you're leaking a route, you're inflicting in many cases on yourself a denial of service attack. So this has business case. Your routing hygiene pays. But it also does other things. First of all, because of its visibility, right? It signals your security forward posture. The thing is, if you look at the internet, you don't know which networks really implement those good practices, not even those, but just good practices, and which are not. And this information sometimes is necessary, right? When you peer with someone, you would like to know maybe what level of hygiene this network exercises, right? If you go for a contract, for connectivity contract, that might be useful information as well. So there is, and this is a general security thing, lack of signaling. This is what is called information asymmetry, which MANRS tries to also help to solve. All right, so increasing adoption. I would like to talk about that a little bit. So MANRS started 4 years ago. We started in November 2014, and when I say we, it's actually network operators that started this initiative. Internet Society role here is more as a secretariat, right? We don't own this initiative. It's network operators that really run this, and would like to, we actually put more efforts to sort of facilitate this ownership of this initiative in the operators community. So that's the sort of how it went. And that's where the year 2018 started. And you can see, I think we really see that it's getting traction. So we went through those phases, you know, phases of change like denial, exploration, you know, acceptance, this kind of stuff. And I have a feeling that it's now more clear for people, this concept. It's sort of, you know, diffused through communities. And with this sort of first enthusiasm of early adopters, then we have this plateau when people are like, MANRS, said, why do I need to join MANRS? And then now it's less of those questions. It's more like, yeah, I think we need to do this. Let's just come together. Let's move on and let's strengthen the effort. I will talk about this a bit later. So MANRS in Europe, that's the map. That's Sweden. So we have 2 operators in Sweden, but there are many more, I think, that can join. I'm more than sure that the Swedish operators, they maintain a high level of hygiene. So it's maybe a lack of awareness, or maybe a lack of motivation, or maybe a lack of understanding why MANRS is important while implement those actions already. So all in all, I think Europe can be greener. I think if you look at real sort of, you know, state of affairs, real level of hygiene, I think Europe is greener. So it would be great to get all these good networks on board and increase the gravity of this effort, right? At the end of the day, it doesn't matter if you have 1,000 members or you have 2,000 members, but in general, I think if those communities, right, where these people operate, right, if they take MANRS on board, if they start talking about routing security, mentioning MANRS, that creates this sort of snowball effect, which I showed you on the graph. It's an indication of a snowball effect. It can go either way, right? So we'll hope it goes up, up to the right. So increasing adoption, how do we scale this up, right? As I said, I cannot go to every operators meeting and make this presentation. Well, people will ban me from those conferences. They will say, come on, we heard this already, or I heard this already. So we need to somehow build partnerships. We need partners, right, that can take this concept and discuss this further in their operation communities. One of the very important partners that was recognized by the MANRS community in the early days were IXPs, right? Internet exchange points, they have their own operational communities with common operational objective, right? That's a great place where you have those discussions. And routing hygiene is very important in IXP environment. I mentioned Brazil. They are running their project around IXPs. They want to implement this hygiene on IXP level because that will solve a lot of problems on these peering relationships. So there is a lot of synergy. And how IXPs can contribute? Well, actually, they can also technically contribute because they are running, many of them, they are running so-called route server that facilitates multilateral peering. So as a member, you join a big IXP, you don't set up peerings with all the other members, you just set up one peering with the route server, and it proxies, right? So that's a great place to implement technical measures, but also social measures. As I said, there is a community that you can have discussions with. So April this year, we launched this program. Sweden's here. Well, it's a random order. I didn't do this on purpose, but it's great that not is there, right? So the community again, IXPs. There was a development team of 10 IXPs that went off and developed those draft actions, looking how IXPs can contribute to routing security, and they ended up with not with 4 existing actions, but they ended up with 5 actions. Right. The most important one, well, the most important are 2. The first one, prevent incorrect routing information, very similar to MANRS, like filtering, right? And that is what happens when the route server, you can implement this action on the route server, and you can say, if announcement that we get from the peers doesn't match with one of the repositories of a choice, IRR or RPKI, we drop this announcement. And there was, by the way, some discussion because the first version of this action set was softer. We'll say, if there is incorrect, we'll just tag and pass to other peers so they can make a decision, because who are we to make those decisions for our members? And then there was a tough discussion, and people say, no, I mean, that will be lip service if we do that, and we'll never come back. We will never be able to strengthen this. Let's set the bar a bit higher. Right? And let's say no. If it's incorrect, it has no weight further than the route server. It stops there. And we implemented this in the action set. We implemented, and we had good IXPs joining and implementing this stuff. So prevent incorrect routing information. And then action 2, which is also mandatory, is more social thing. Promote manners in your community, right? Ignite your community to implement those things. Because it's also important. There is also a benefit for the IXP if members are exercising higher level of hygiene. So while MANRS sort of works on securing customer cone, your customer-provider relationship, IXP program works on securing peering relationship. And well, there is nothing left. So with those 2 programs, I think we're very much in place to, it's just a matter of scale to secure internet routing. Okay. So another thing that we were working on is one thing is increasing adoption by providing incentives, by providing information. Another thing is providing tools, reducing the costs, the threshold, how you adopt this stuff. So again, community of network operators went off and created this implementation guide. It's now published as RIPE document, the abstract, not the whole guide, but it details how how a network can implement those actions. Because the actions, if you look at the document where actions are described, it doesn't provide, it's not prescriptive. It doesn't say you have to use IRR or you have to use RPKI, you have to build this or you have to build that. It looks at the outcomes, right? It says, well, you should take measures to prevent incorrect routing announcements. Incorrect routing announcements going beyond your network. You should be a stop here. But implementation guide provides real practical examples how this can be implemented. Training. Well, maybe it's in some countries that's less relevant, but in some countries they really lack expertise, right? And what we did online modules based on this implementation guide. We create online modules. There are 6 online modules where people can just at their own pace take part on and better understand how those actions can be implemented, with some quizzes as well. So anyone can look at this and can do that. And we also, we have at Internet Society, we have Inform, and that's an online learning platform which can track sort of progress and can allow to create moderated classes. So if there is interest and say, hey, for our community would like to have a moderated class, then that's also possible using the ISOC platform. Another thing that we are about to complete, and I'm very excited about that, is that we are building an online lab. It's a web-based lab with real sort of things. That's the topology. That's the network. Well, this network has only one router, but the idea is that you have a bare-bone network and you need it configured to be MANRS compliant. And how we position this lab, it actually supports Cisco Juniper MikroTik, but it's expandable, or extendable, right? It might support other platforms as well. So here are your clients, here's your upstream provider, here's your peer. All of them can send various garbage to you, right? Or both in terms of routing announcements, both in terms of spoof traffic, right? And you have to make your network MANRS compliant, and we'll also see the effect of that, right? So yeah, that's your network, and while you configure that, you will see those becoming green, meaning you are protecting yourself, you are exercising this high level of hygiene, even if those networks do not. We position this, we also want to partner with training organizations. ISOC is not a training organization per se, but would like to partner with training organizations in a wider sense of this word, right? That this lab can be used as an and exam. So if, for instance, you're running, or any of you are running like BGP training, right, or network security training, right? It has many facets, many aspects, and MANRS is just one little piece. But this lab can be used as an and exam. How well you understood general concepts about BGP, about filtering, about configuring your router. It's a 1-hour lab with tests and checks, so it's quite easy to do. In December it will be ready and will be available online for people who are interested. Web-based, so you can log in, you can configure your lab. I think we are sorting the license issue, but that's the way to go. Another thing is that right now on the web page you see MANRS members and you don't know what level of MANRS readiness are there. And I heard from some of the people that, well, this MANRS is just a website. I mean, people put their names, whatever you like. If you want to join MANRS, just send them a mail and you will get there. I mean, we know this type of websites, right? They exist. So people confuse MANRS with those websites. And indeed, on the MANRS website, it's not transparent enough. People do not know that when the network joins, they go through the evaluation process and we run some checks to verify, to a certain extent, it's not 100% of course, to a certain extent that those actions are implemented. So what we want to do, we want to improve transparency and credibility of this effort, right? So people can take seriously what they see on the MANRS website. We call it MANRS Observatory and MANRS Dashboard. So ultimately, we would like to indicate level of MANRS readiness for the participants, right? Once they're comfortable with the sort of data we collect, but also we would like to. I showed you some data and dynamics, right? That was just one-off, right? Sort of research, but would like to show those trends on a long-term time frame, and that's what we call MANRS Observatory. So people can compare, for instance, how routing security or level of routing hygiene in different countries, different regions, and maybe at some point in different networks. So I'm very close to the end of my presentation. You wanted to say something, or you wanted just to speed me up?
Yeah, yeah, exactly.
Yeah.
Thank you.
Yeah.
Yeah.
So why join MANRS? Of course, improving your security. Demonstrate that practices are reality. They're not just on paper. Those people that are on the MANRS participant list, they implemented those actions. Join the community and use MANRS as a competitive differentiator. Yeah, well, we skip the poll.
Yeah. Yep. Well, thank you very much, Andrei.
Thank you.